Alright, I've been doing some programming on the STM32F4, the one that I made from scrap, which I found. This one. So the program at the moment was doing is it's going between programmable interval counters, timers, or PIT, which is basically the sound generation end of like a DCO synth. So it's going to load up that, it's going to load the value 100 Hz. This is the last time it ran. Just a serial output, so that's the number 19090. It's going to put that on the binary form on the red cables. It's going to tell the chip, come on, write. It's going to write that value to the data bus. It writes the first, it's a 16-bit number, but it's only an 8-bit wide bus, so it writes the lower byte first, and then it writes the high byte, and that stays latched on the bus to high byte, so you can read off the bus with a high-low what it is and whether it's right or not. I had a little bit of a stuck bit scenario because the boot pins, one of them, it doesn't even say it in the where you assign the pins in here. It tells you boot 0, but it doesn't tell you where boot 1 is, and not even if you look. So that one, it doesn't say. You can select, it can be used as boot 1, which is a bit weird really, because yeah, they all kind of all come with a boot 1. Oh, obviously this one is reserved, that one isn't, but they could let you know. It's in a data sheet, but anyway, that was resolved. So then it was passing the right number, so turn the scope on, we got a light coming on. It doesn't have a light, of course. This is just one of these, so I actually took these out of a JX8P, which I upgraded to a different form of counting, a different system, so I desoldered these chips, but they still work, so I'm going to make my own. 4 of them are 6 voices, so presuming 6 of them would be 8 voices. I want something with 8 voices, so I'll probably get another 2, and then they all just run in the same chip select, the same bytes and everything. They've got 3 counters in there, so you can have a sub oscillator running at, you know, exactly 1 octave below and stuff like that, and turn that on and off in the software. So yeah, that's the output. It's not the most accurate scope, so it is 100 Hz. So yeah, that's the square wave, 50% duty cycle. Really a tiny bit, isn't it? So it's like locked onto that one. I think it goes out a little bit there. But the duty cycle not wavering, but the time base seems to be. But anyway, that's probably just the scope as well. It's kind of a basic model, this one, but I put a silent fan in it, and at least that has improved it massively. It went from 42 decibels, which is like a loud dishwasher, to 9. So it's practically inaudible. So yeah, that's great. The next step is like doing a MIDI parser, basically. So you're going to map MIDI notes to frequency, and then when it's in the code, there's just a part that then tells it, yeah, take the frequency. Where's it gone? Just have to print the value. Let's just look for 100. There we go. So you can set the frequency in there, and then it will just write that as a 16-bit number in 2 halves. So it'll just slam the first one over, then the second one, and then it just starts producing that frequency, whatever frequency that's at. So it has to tell it what mode to be in first, and then it'll do that. There's quite a few simultaneous projects. So yeah, you set the mode up on the right, and the A1 and A0, the address lines, and actually no, you set the mode right on the data bus. You select what counter you want with the A1 and A0, so you'll say like, okay, go into mode 3, square wave generation. These 2 low, that's counter 0, then 1 high, 1 low, counter 2, both high, counter 3. Finally got this working with MIDI input. It was a baud rate issue the whole time. I have tried it with different boards the other day, so it must have been another issue the other day. But after I looked on the scope, I was fucking off for ages trying everything, all different ways of getting the MIDI in there. It was actually just the wrong baud rate by like 2 or 3, well, maybe like 8 microseconds. I put it on to be 31250 MIDI baud rate, but it was actually doing something like 2850, you know, so it wasn't reading good data, or it wasn't coming in at all. So yeah, with that changed it is now, and you can just move this a little bit. Here's the thing, so it's getting the target. So it's calculating the note. Alright, 325, and then that's the reload value, and then it's giving you. It's not calculating this properly, but that's just a print thing. It's not wrong. When you go down really low, it gets to the maximum. That's the cap, basically, at this clock speed. Yeah, I've been making this MIDI to go out to use with, well, yeah, I guess projects like this. It'll probably stay as a breadboard thing, just for microcontroller tests. It's responding to notes, and it's changing the actual output frequency, which is what we're scoping here, inaccurately scoping. It does have a lower limit and an upper limit, but yeah, that's changing, so that's a great success.